Have you ever wondered how fish communicate in a world without words? Good day, everyone. I'm Rosinda Maca, and today, along with my group members, we'll explore the different ways how fish communicate, how they send and receive messages, how these signals work, and why they are so important for their survival and even for their reproduction. But before we start, let's look at what we aim to achieve today. By the end of this presentation, you should be able to: number one, understand the types of signals. So throughout this presentation, we'll define and give examples of the communication method in fish, such as the visual, acoustic, chemical, and electrical. Number two is to explain the signal production and reception. So we're going to discuss how fish actually create these signals, like vibrating their swim bladders or releasing chemicals, and how other fish detect them using their senses. And number three is to analyze environmental effects. We'll explore how things like water clarity, currents, and even human-made noise can affect how signals travel and are received. And number four, the last one, is to discuss evolutionary significance. Finally, we'll look at how these communication methods have evolved over time due to natural and sexual selection. So, what exactly is communication? In simple terms, it involves a sender encoding and emitting a signal, the signal itself, and a receiver whose systems decode that signal. And for fish, this is a truly multisensory experience. Their communication involves visual, acoustic, chemical, and electrical channels. These channels are closely linked with their physiology, their senses, and how they generate signals, and their behavior, like specific movements or social interaction. So, what counts as communication? To be considered communication, there needs to be a sender, a signal, and of course, a receiver. So, the physical properties of water, such as its density, viscosity, and how light travels through it, really shape what kind of signals are effective. What works on land might not work underwater, and vice versa. So let's start with the visual signals. Colorful fish are nice to look at, right? But did you know that these bright colors, patterns, and even their body movements and dynamic movements they use it for their communication? Think of courtship displays or aggressive posturing. These are used for attracting mates, recognizing species, and even establishing dominance. So the effectiveness of visual signals depend on the fish's ability to see certain colors and how well the signal contrasts with the background light. So as you can see in the example, we have fish with bright colors, and we have what we call this, the bioluminescence. So next we have chemical signals. So these signals is often called as secret messages that sent through the water. So have you ever heard of pheromones? So pheromones are chemicals that were released by the fish in the water. So these signals can convey crucial information about the reproductive status, even signal danger such as alarm cues or identifying the individuals or groups. Then these signals spread. Next, we have the acoustic signals or the sounds. Many fish produce sounds by vibrating their swim bladders or through rubbing parts of their skeleton together. These sounds are really useful for defending territories, attracting mates, and coordinating group movements, especially in conditions where visibility is poor. So sound travels very efficiently underwater, often farther than visual cues. In our terms, it's like they are talking using sound, but underwater. These acoustic signals are generated in various ways. For example, is the swim bladder vibrations. We also have rapid muscle contractions or skeletal elements rubbing against each other. They can convey information about identity and motivation, and are especially important in dark, deep or murky waters and during nighttime. Next, we have electrical communication. Some fish, particularly those living in murky waters or active at night, they use electrical signals. Weakly electric fish can generate and detect electric fields, so this is useful for navigating, finding prey, and communicating with each other. And we also have the mechanosensory communication. So as we all know, fish have a lateral line system. So they use that to detect vibrations and pressure changes in the water. So this plays a crucial role in a close-range communication, especially when other signals might be limited. Now let's talk about the evolutionary forces and trade-offs. So, why do these communication methods exist? They evolved under the pressures of natural selection and sexual selection. Natural selection favors signals that help fish survive, like camouflage or alarm signals. Sexual selection, on the other hand, often drives the evolution of exaggerated traits that help attract mates, like bright colors or complex displays. They need to balance the benefits of the signal with the cost, like energy expenditure or becoming a target for predators. So let's talk about environmental change and conservation implications. Unfortunately, human activities are significantly impacting fish communication. In what way? Things like chemical pollution, increased turbidity from runoff, and noise from shipping and development can disrupt how fish produce, how they transmit and receive the signals. These problems because really affect their lives. For example, chemical pollution can interfere with reproductive and alarm signals. Noise can mask acoustic signals, making it hard for fish to communicate over distances and increasing the energy they need to expand to be heard. Habitat changes can alter visual backgrounds and water flow, disrupting various signaling channels. And that's all. Thank you for listening. God bless everyone.